This is video tutorial number 8 of the Europe-LAND Toolbox video tutorial series. In this example, we explore urban fabric expansion versus flood risk, using the Europe-LAND Toolbox version 1.6. This example focuses on urban fabric expansion between 2000 and 2018, and how this expansion intersects with flood-prone areas. The study area is the Thessaloniki Metropolitan Area, in the region of central Macedonia, Greece. Using multiple data layers and comparison tools, we examine how urban growth patterns relate to potential flood risk over time. The purpose of this example is to evaluate how the city expanded between 2000 and 2018, and to assess how this expansion overlaps with flood-prone zones, and also to identify current and emerging flood risks and support evidence-based planning for safer, climate-resilient urban development. For the analysis in Example 1, multiple data layers and tools will be used: NUTS, administrative boundaries, elevation data, CORINE land cover for the 2000 and 2018, imperviousness density, tree cover density, and flood-prone potential areas from the European Environment Agency. Moreover, to compare these datasets properly, we will also use the compare tools, and in particular, the slider tool, to visually explore spatial changes and overlaps. This example is relevant to a broad range of stakeholders: decision makers at local, regional, and national level, authorities responsible for flood risk management, urban and spatial planners, civil protection agencies, landowners and developers, farmers and agricultural cooperatives, as well as infrastructure operators. The innovation of the Europe-LAND Toolbox lies in its ability to combine multi-source geospatial datasets with interactive comparison tools, offering a rapid, visually intuitive way to detect conflicts between urban growth and natural hazard exposure. Unlike standalone GIS viewers, the platform enables instant cross-layer analysis, supports open data integration, and allows non-experts to explore spatial risks through simple tools such as sliders and dynamic overlays. This slide presents the so-to-speak cheat sheet of Example 1. If you have already watched this video and you want to replicate Example 1 on your own, we suggest you pause the video here and use the cheat sheet for assistance. If you need more help, or if this is the first time you watch this video, we suggest you continue to watch and perhaps try to replicate what you see, pausing the video if necessary, whenever you need to. This slide actually briefly presents all the steps you should take in order to recreate Example 1 as shown in this video tutorial number 8. On the left, you can see the exact buttons/layers/tools you must click and use. For example, Step 1 includes the following. You start by clicking the Data button in the Data panel, then you must click the Layers button, then you must click the NUTS regions button, and then you must click Level 0 button. This was Step 1 of the 8 steps of the main part of Example 1. Then you just follow the next steps, while on the right of this slide, you can see the respective steps of some additional features we will check. Let's test Example 1 together. This will deepen your knowledge and skills on the use of relevant layers and tools. In the next part of the video, we will walk step by step through the toolbox to reproduce this example. After closing the pop-up welcome screen, just click Layers. Let's go to NUTS regions and click Level 0. It automatically zooms out to the extents of Europe. Let's zoom into our study area, the metropolitan area of Thessaloniki, northern Greece. In this transparent layer, if you click inside the respective NUTS 0 administrative region, you can see a pie chart with the overall distribution percentages of land uses from 2018 in this region. You can also click Export PDF and read and download these data in a PDF format. So if we close this, we can see that NUTS 0 layer was added to the layer manager on the upper right part of the map and screen. If we add NUTS regions level 3, again it zooms out automatically to the extents of Europe. Let's zoom again in our study area. We can unclick NUTS 0. Now we can only see NUTS 3 regions. If we click in the respective regional unit of our study area at this level, we can see the respective distribution percentages of land uses there. Let's now go to the European Environment Agency, or EEA, and load the elevation layer. It may take a few seconds to load this layer. We can now see the respective legend in the lower right part of the map. We can see the color scale from blue, low elevation, to brown, high elevation. Let's go to the Copernicus button and load the CORINE Land cover layers for 2000 and then 2018, which allow to examine urban expansion over time. We can see the legend on the lower right part. We also see that the layers were added in the exact order that we clicked them on the Layer Manager in the upper right part of the screen. Now let's add the imperviousness density layer for 2018 and also the tree cover density layer for 2015, noting that at the current moment the 2018 tree cover density is not available from the Copernicus server. Let's now load the last layer for this example, flood-prone potential areas from EEA. It takes a few seconds to load too. We may zoom a bit more in our study area, the metropolitan area of Thessaloniki City in central Macedonia, Greece. At this point, we can start combining layers in order to compare patterns and draw spatial conclusions related to urban expansion and flood exposure. First, we examine the elevation layer to understand the topography, slopes, and low-lying areas, which are critical factors in flood risk. Now we activate CORINE 2000 and CORINE 2018. These layers are not transparent, so by toggling the upper layer, CORINE 2018, we can clearly observe changes in land use over time. We can select the legend of CORINE 2000 or 2018. All CORINE layers actually have the same default legend. Here, we can clearly witness the expansion of urban fabric and industrial areas between 2000 and 2018. We can also identify major infrastructure developments, such as the construction of the ring road, during this period. Next, we activate the imperviousness density layer of 2018. Since it is transparent, we can overlay it on the CORINE layers and directly relate sealed surfaces to patterns of urban expansion. We also inspect the tree cover density layer, which requires a different zoom level. Being transparent as well, it allows us to assess green coverage in relation to urbanized and impervious areas. Let's now overlay the flood-prone potential areas layer on top of CORINE 2018. At this stage, users can visually evaluate where urban expansion intersects with flood-prone zones, helping to identify areas of increased or emerging flood risk. In the southern part of the study area, we can observe the Anthemoundus River, which is particularly important since Thessaloniki's airport is located in its delta. This area appears as high flood-prone potential, with the airport that was expanded recently clearly visible within this zone. We can also witness the significant expansion of the industrial area in the northwest, in Syndos area, that is near the Gallicos River, whose riparian area is a typical flood-prone potential area. We can also compare layers and draw spatial and temporal conclusions using the compare tools and specifically the slider tool. This corresponds to Example 1, Additional Features A in the cheat sheet. Let's zoom in the study area of example 1, the metropolitan area of Thessaloniki, Greece. Let's select as a left layer CORINE 2000 and as a right layer CORINE 2018. We can use the slider and compare the two layers. Next, we compare CORINE 2018 with the flood-prone potential areas. After the right layer loads, this comparison helps reveal how recent land use patterns overlap with flood susceptibility. This corresponds to Example 1, Additional Features B. We then compare imperviousness density 2018 with flood-prone potential areas, allowing us to relate sealed surfaces directly to flood-prone zones. This is Example 1, Additional Features C in the cheat sheet. This was Example 1, Urban Fabric Expansion versus Flood Risk. Through this example, we evaluated how the city expanded between 2000 and 2018, and how this expansion intersects with flood-prone areas. The example illustrates how the Europe-LAND Toolbox can support evidence-based planning, helping identify current and emerging flood risks and contributing to safer, more climate-resilient urban development using openly available data and intuitive comparison tools.